Example number 2 on page 20. A function and its derivative take on the values shown. If g is the inverse of f, find g prime at 6. This is the inverse function of f. Now, what do we know? Let's apply our rule. The derivative of the inverse function, this is g is already the inverse function, that derivative of that at a certain value, in this case the value is 6, is nothing but the reciprocal, 1 over the main function's derivative, the derivative of f, assessed at the reciprocal, assessed at the inverse function at 6. Notice that this is x, this is x. This is the derivative of the inverse function, this is the inverse function. Okay, so how much is g of 6? Let's have a look at our table. We don't have values of g, we have values of f of x. But because we already know how to deal with inverse functions and we know that x and y switch roles, we can say, let's say from here, for x2, f of x is 6, then g of 6 should equal how much, people? I hope you all said 2. And here we can say that g of 8, the inverse function at 8, should equal 6. Notice x and y switch roles. Now, knowing that, let's go and replace values. Okay, let's see. This is 1 over, remember, we are going to do the inside and then the outside. F prime, how much is g of 6? Oops, g of 6 is 2. Now all we need is f prime at 2. Do we know f prime at 2? Let's see, f prime at x2 and f prime at x6. Yeah, we know f prime at 2. F prime at 2 is 1/3. So the inverse, the derivative of the inverse at 6 is nothing but, this would be 3. Yeah? Let's see yet another example. Now this is a different example. They give us a whole function. And they say let y equals x cubed plus x minus 2 and let g be the inverse function. Evaluate g prime at 0. So let's apply our rule. G prime at 0, since g is an inverse function, will be nothing but the reciprocal of f prime assessed at g, the inverse assessed at 0. Huh? So the first thing we need to know, going from inside to outside, is figure out how much is g of 0. Yeah? So first step, we are going to find g of 0. Yeah? Now, if we switch roles, we know y equals x cubed plus x minus 2. We know that this is the main function. So if we switch roles, x for g would be y for f of x. So we say 0, x of g, 0, equals x cubed plus x minus 2. Now it's interesting because we could factor here, or we could say, okay, x cubed plus x equals 2. Now, can anybody tell me a number that when added to its cube equals 2? Think of it. There are not many of those. Yeah, the number is 1. So x equals 1. Yeah? That means that if we switch roles, g of 0 equals 1. Why is that? Because we have switched roles, because f of 1 equals 0. We did f of x equals 0, f of 1 is the one that equals 0. That's the first step. Now we know this little value here. This is 1. So the second step would be to find f prime and evaluate for g0. Yeah? Let's see. If f of x is x cubed plus x minus 2, then f prime of x is, that's easy peasy for you, 3x squared plus 1. Yeah? Now what we want to do is find f prime and evaluate for g0. In other words, what we want to do is find f prime of g of 0. Or, which is the same, f prime of 1, because we have just figured out that g of 0 is 1. And this would equal 3, 1 squared plus 1. So f prime of g assessed at 0 is 4. Once we have this value, then we can finally find the initial expression. We can finally say, okay, g prime at 0, the derivative of the inverse function at 0, is 1 over the derivative of f of x assessed at g of 0. We have assessed the derivative of f of x at g of 0, and that's 4. And that would be it.